All right, so 5.4, Foundations of Math 20, the normal distribution. We've been talking about statistics. We've been talking about mean, median, mode, talking about range. Talked most recently in 5.3 about standard deviation and what that sort of means. The standard deviation is the dispersion of the data points, right? So how spread out they are. Use that quick example. Two math classes both have an average of 82%. The range for one is 80 to 84. That's it, all of them. The other class, the range is 30 to 100. There's obviously a difference in the dispersion or the separation of those marks, and standard deviation would help us to understand that. 5.4 talks, this is about standard deviation as well, but it's called the normal distribution. So when we're talking about distribution, we're talking about the distribution of data items in a set. So if we talk about a math class, you know, if we had a math class of 1 million people, okay, what the marks would spread out in a fairly predictable way. This is what statistics shows us. Now in a smaller class, they may be all over the place, but a normal distribution is sort of what happens when you're given a situation and you're taking data points, you know, you're making measurements for the same situation. You're going to have some marks that are high, some marks that are low, some marks that are around the middle. And most of the marks, it turns out, are going to be around the middle. Now, if we, you know, there's a number of different activities we could do. We could roll dice 50,000 times, all right, and we could kind of count, you know, what numbers show up. That would take us a long time. Certainly, if we were to do an activity like that, we would see one of these four patterns show up. So if we rolled two dice or a die 50,000 times, and these graphs right here represented the numbers that you could get, okay? So I know there's more than 6 of them, but let's just say these are the numbers from 1 to 6, somewhere around here. What pattern do you think we would have? Let's say 2 dice, okay? Because one dice doesn't really cut it. It's got to be 2 in order for this to be real. So 2 dice, and if we did it 50,000 times 2 dice, and we took the sum of those dice, okay? So that's a better example. What do you think would happen? Would we get, you know, an equal number of every possible sum? Would it be kind of, do you think that it would be pretty loaded on the high end? The high sums, like 10, 11, 12, would be the most frequent, let's say. Do you think that there would be sort of 2 peaks like this, where you get a whole bunch of small sums, like lots of 1s and 2s and 3s would show up, and then lots of 5s and 6s would show up? Or do you think that it would be sort of like this, where you would have a few really small sums, like 2 and 3 and 4, a few really high sums, like 10, 11, 12, but a lot of sums kind of around the 5 to 8, you know, 9 range? Which one of these do you think, you know, would happen? What would be your guess? Anybody? The blue one. Okay, help me with my, is this blue?
Yeah.
Okay, blue one. Anybody else vote for the blue one? Okay, any other ones? Okay, that's a good guess. There's no right or wrong answer at this point because you don't really know much about what's happening. How many of you know when you roll 2 dice, is there a sum that shows up a little bit more often than others? Usually, I don't know how many of you have experience with this. Do you know of a sum that would show up more than others? There actually is one that has a greater chance of showing up. 6? Not quite 6.
7?
7. It is 7. Now, why is that? Okay, I don't know if I want to take the time to show you why that is, but think about the combinations of numbers on dice that would add up to 7. We have 6 and 1. We have 5 and 2. We have 3 and 4. Okay, there's different combinations. How many options do we have for 12? 1, a 6 and a 6. How many options do we have for 2? 1, a 1 and a 1, right? And so there's not a lot of chances that you would get those sums, but there are quite a bit more chance that you would get the sums in the middle. So it actually is this one right here, okay? It's this distribution. This is called the normal distribution, okay? That's called the normal distribution. So good guess here. And again, there's no wrong guesses for that one. So let's copy down. Let's take some notes here on the normal curve and the normal distribution. So we'll just take a clip of this as I put it into our notes, and we'll just read through that. All right. So there's the normal curve and the normal distribution. So this would be 5.4, the normal distribution. All right, so as we read through this here, the normal curve, okay? You should be jotting this down. Get this down in your notes. Summarize it or copy word for it, doesn't matter. Take some time to ingest this, okay? As you copy it down, as you sift through these words and put them on your paper, you take a few minutes to do that. It'll help you get it into your mind. So as we read this, a symmetrical curve. Okay, symmetrical means that you can split it in half and it's identical on both halves, right? It's symmetrical. That represents the normal distribution. It's also called a bell curve. Maybe you've heard of that. So it kind of looks like this, where there's sort of a, comes up to a peak, and then it's symmetrical on the other side as well. So it's kind of like that. It's like a traditional sort of nice-looking wave or something like that. Okay, not like an ocean wave like this, not like that, but it's kind of like a bell curve, and you can see the bell, right? There's the bell right here, ding dong, Okay, so it's a bell. It's not a bell, but it's like a bell. Okay. So the normal distribution, data that, when graphed as a histogram or a frequency polygon, so think about this as a histogram here, right? I'll just draw a few. Okay, histograms or frequency polygons. So that would be, let's say we have, points that are gathered, something like this, and you connect those dots with lines or whatever. So a frequency polygon results in a unimodal. Okay, unimodal. So uni means one. Mode, mode is sort of what happens most often, right? When we talk about the mode of data. So a unimodal symmetric distribution about the mean. So the average or the mean is right in the middle here. And on the bottom you would have sort of all the like, let's say we're talking about a class average for a test, right? So here's the mean. And then if you kind of so frequency polygon would be number of tests at these marks. So as the marks get higher, there's fewer test marks that would be up here, okay? Maybe some 98s, 99s. In your case, that last test, there were a few 100s. Good for you guys, okay? The normal distribution would say that there would be an equal number or an equal frequency of tests that would be very low as well. Now, in a class like this is not my hope, of course, that we have some people down here and some people up here and a lot of people in the middle. My hope, of course, is that we are not normally distributed, but we're more like this, right? This would be great. I think that would be awesome. We have most of the class up here, and that's, but that then wouldn't be the mean, right? If this is the mean, we've got, anyways. You kind of know what I'm saying, okay? But a normal distribution. So in our class, we have 32 kids in this class right now. If we took 1 million kids, that were all in this same class across the world, all right, the marks would come out pretty normally distributed. Okay, that's just sort of what happens. Any questions so far on that? No? Okay. So let's get back to the notes here. Where is that? Okay, over here. All right, so if you take a look at this right here, examining the properties of normal distribution, here's a frequency table. And we're talking about, what are we talking about? Heights, is people heights, or is this lengths for snowboards or something? Anyways, I guess maybe we're talking about heights of people. So if you look at the numbers on the right, you can see that there's a big bulk in the middle. You see that? A lot of people making up the middle part of this chart. Not very many people on the low end, not very many people on the high end. This would be sort of classic normal distribution. Okay? Just like test marks. Heights would be the same thing. Okay? All right. Here's another graph we could look at. Heights of adult men. Okay? So I'm not sure where this is, or if this is in a certain country, or if this is global or what. But in inches, they're saying that the mean is pretty close to maybe 70 inches here. That would be the average height. There would be some that would be less than that, fewer and fewer that would be quite a ways from that mean. And there would be some that would be taller, but very few that would be quite a ways from the mean in this direction as well. So that's not a perfect bell curve, right? But it's generally fairly normally distributed. Okay? Distributed? Okay. Okay, we good so far? Let's take more examination of this, and I think, let's go here. Okay, example 2. So example 2 in your textbook, in this particular example, Jim raises Siberian Husky sled dogs at his kennel. He knows from the data he's collected over the years that the weights of adult male dogs are normally distributed with a mean of 52.5 pounds and a standard deviation of 2.4 pounds. Jim used this information to sketch a normal curve with. Now, we're going to find that in this normally distributed curve, there are some things that we can know about how the data is spread out. And so this is starting to be, this is important stuff. 68% of the data is within one standard deviation. Now, I don't know if you guys remember the other class where I said most of the data they'll all be kind of within 3 standard deviations of, and the standard deviation comes out to a number, but what we're talking about here is groups of those standard deviations. So one standard deviation is not 1 mark or 1 pound, it's 1 sigma. So if the standard deviation in this case was 2.4 pounds, 68% of the data would be 2.4 pounds above the mean and 2.4 pounds on this side of the mean, less than the mean. Okay? So I'll say that one more time. Here's the average right here. You see that? Here's the average. The standard deviation is 2.4. So from 52.5, let me just zoom in there a bit for you. So from 52.5, you add 2.4, you get 54.9. You see that? This right here, from here to here, is 1 standard deviation. Okay? That's 2.4 pounds. And what that means is, here's our curve, and the next number we would put up there would be the 1 standard deviation. So you add another 2.4 pounds. This is 2 standard deviations away. Add another 2.4 pounds. This is 3. And notice that a very small percentage of the data would be beyond 3. So most of the data, and actually 99.7% of all of the data, if it's normally distributed, would be between 3 standard deviations from the mean. Okay? I know this is terribly exciting. That's why I gave you the pep talk at the beginning of this class. There's a lot of numbers, a lot of percentages. Okay, so just bear with me. Some of you are nodding off. And I'm glad that my monotonous voice puts you to sleep at times. But anyways, try and stay with me. Okay, so here's 68%, here's 95, and here's 97. All right? So what this is going to do is we are going to be able to draw a normal curve. We're going to be able to guess, the percentage of the class, let's say, for our marks that would be, 68% of the class, let's say, would be between this mark and this mark, and so on. So for statistical analysis and things like that, these curves are good. Now for small classes, we may not have a perfect normal distribution, but sometimes, and you've probably heard of this before, have you ever heard of teachers curving marks? Yeah. Okay, have you ever heard of that? Okay, some teachers do that. I even do that at times. But when a teacher curves marks, what that means is, okay, just briefly, what that means is that we would have something like, maybe this happening. If we go back to this one, we would maybe have something like this happening with our marks. So we have a lot of people down here, and let's just say this was an exam where there was some either errors or some questions that actually turned out to be a little bit unfair or a little bit confusing or whatever. That happens, right? Teachers, make questions and then they look at it again, or you guys notice there's a number wrong, or there's a word that actually could mean more than one thing and you're legitimately confused, or whatever. So for whatever reason, sometimes marks are skewed. If the test is good, teachers usually just leave it alone. But if there's some problem, a way to correct that problem, or a way to say, let's just correct for this bias or whatever, they will curve the marks. So what that means is you could actually, maybe the average is down here, you could say, you know what, I am going to set my average, and again, it doesn't happen very often, but this is what it would mean. Set the average to a certain average. If the average is 70, you want to set it to 75 because that's pretty typical. Then you go up to 75, and then you would say, well, we're going to normally distribute the marks. So that means that this person right here, that maybe got this mark, would actually now be pushed to this mark. Okay? This mark here, right, would kind of be pushed over to this mark to form this normally distributed curve. Now, if we had something like this going, it could mean, not often does it happen, but if we had something like this, it would mean that maybe some of the top marks would be shaved down a little bit to correct for the bias as well. That doesn't happen very often, but when the marks are curved, they kind of squish it up and make it a nice bell curve, and that's kind of how it shakes out. Most people, and it's kind of like, the class is then normally distributed. It's sort of how it should shake out anyways. Do you know what I mean? So with small classes and on general term, that doesn't happen very often because usually it shakes out pretty evenly. Or it's up over here and the test is not bad and teachers are fine with that. But that's what curving means. They force all the data into this normal distribution. You find the standard deviation, and so the data is now, instead of being peaked to one side like this, it's the peak is brought over and then it's spread out a little bit, normally curved, so it all kind of shakes out to be that normal distribution. Make sense? Yeah? Okay. All right. Okay. Let's keep going. Again, this is a lot of just sort of understanding comprehension stuff. So I'll move through this a little bit more. Okay. Actually, I'm going to go to, if you take a look at the key ideas there in your textbook. So just at the end of the chapter, you know what, there's a lot of good stuff in here, but I think I just kind of want to settle on this a little bit. This will get you most of your understanding right here. This chart's great. Okay. As we know, 68% in a normal distribution is within one standard deviation of the mean. Now here they've got the mean as this Greek letter. I think that is mu. I'm not sure. I think that's mu. Put on the spot here. X bar. Okay, so X bar plus one standard deviation would be exactly 34% of the data. So 34% of you would be between the average and one standard deviation above that average, whatever that would be. Okay, so there's another 13.5% here, and you should sketch this out. You should sketch this out, so I would encourage you to take 1 minute. It's not going to take you long. But sketch this out. This is important information for you to refer back to. And as we get further from the mean, the number of test marks or data items become a little bit less. So this is a normal distribution. So just take a minute to sketch this out, those percentages, and this is important for you. So just give you a second to do that. All right, so just a few of the things that you would need to know here. The properties of normal distribution can be summarized as follows. The graph is symmetrical. Okay, we know that. This is also something that's interesting. The mean, the median, and the mode are equal or very close to being equal and fall at the line of symmetry. So this average, this is the mean. The median would be here. The mode would be here if things are perfectly, normally distributed. The normal curve is shaped like a bell, peaking in the middle, sloping down towards the sides, and approaching zero at the extreme. So it doesn't really ever actually hit zero. It kind of approaches zero, but you'll see that the line appears to be connected. That's fine. Up there is it's whatever. Okay. It would approach zero, which again, calculus stuff. Approaching zero is not exactly equal to zero, but about 68% of the data is within one standard deviation. 95 is within two standard deviations of the mean, and again 99.7. 100% of the data would be represented on the table. This would be considered to be 100% would fall under here. And then just a final note here. Generally, living things, things, these kind of things, mass, height, length, different things would be normally distributed. There's lots of things in the world, like temperature, that sort of thing. Might not be, but again, random sort of test marks and stuff like that would approach a normal distribution given a large number of students. Okay, so what kind of things are you going to have to know how to do given this information? So let's just briefly look at some of the questions in your assignment. Number one, okay, This question says the ages of members in the seniors curling club are normally distributed with a mean of 63, so that's going to be your middle number, and a standard deviation of 4 years. So on your graph, you have 63 at the middle. One standard deviation to the right is going to be what? What's that next number you're going to put there? 67, right. And the next number, another standard deviation of it is going to be 71, and so on, right? So you see that? That's how you make your graph. And then they're going to ask you as well, what percent of the curlers are between 55 and 63? So you're kind of looking, right, at this graph, and you're kind of determining where's my percentages and stuff like that. Okay? So that's one thing to be asked about percentages. This one, number 3, here's some data in a frequency table. They're asked you, does it look like this is normally distributed? That's what it's going to say. So here we have our low end and our high end. Each of these intervals are even, and so we seem to have a low number on either end, and it starts to kind of get higher in the middle. This number is not the same as that one, but is it close? So what you could do is draw the frequency table and very quickly just sort of sketch some intervals, right? So here's your intervals, and you could put the numbers there, and then just put a dot in the middle of the interval, whatever. So if it would look like this, you would say, is that normally distributed? And if it's pretty close, you could say yes. If it obviously peaks twice like this, you could say no. If it's like this, you'd say no. If it's like that, you'd say no. But if it's something close to being around the middle there, you would say yes. Okay? So that's something that you'd look at. All right, so it may give you a question like this where you have to plug this into your calculator. Find the standard deviation and the mean. And again, that'll be pretty easy. Put that into your list. 1 var stats for list whatever. Hit enter. All shows up on the screen. So what we're doing is we're basically adding the normal distribution table to some of these questions. Okay, so I'll give you your assignments, and you can get a start on that. You've got some time to do that. So 1 to 3, 6, and 10 would be a suggested assignment for you to do here. So 1 and 2. There's your data for 3. There's 6. And there's 10.